This is the Management 560 Introduction to Game Theory. This video and slides are meant to complement the reading from the textbook. Um, Game theory is the study of strategic interaction. So there's plenty of interacting in life and in business that's not competitive in nature. So we do lots of our time is spent coordinating with people and working together in teams to try to get things done. Game theory is not the study of those behaviors. Game theory is the study of when we're acting strategically, generally in our self-interest, to try to get the best outcome, assuming we're dealing with other selfish people as well, or entities. So game theory as a discipline assumes that generally assumes that players in these games or parties to these interactions act rationally. They're seeking to get the best outcome for themselves. They assume that other people are also trying to get the best outcome. And so this kind of situation, it accurately models a competitive business environment, like an oligopoly, for example. So if I'm Boeing and my competitor is Airbus, we are not out to help each other succeed. We're out to help us succeed. And if that helps them succeed too, so be it, but we want the best outcome for ourselves. So the interaction, the interactive behavior between Boeing and Airbus would probably be modeled using some kind of game theoretic construction. So in 560, we'll be studying simple introductory games where there are just two players and they will make just one move. But you can extend this to more players and more moves and make it more complicated. But we can get some of the intuition for how game theory models work and actually be able to make some conclusions using them just from the simple setup we'll cover here. So a classic example of a game theory style game is rock, paper, scissors. So it has a couple components that'll be consistent with the games we'll study. It's a simultaneous move game. So, you'd say rock, paper, scissors, and then show, everybody's moving all at once. So you don't get to respond based on your opponent's action in the same round. We can also call that hidden action in that, you make your choice without the other player knowing, and they make their choice without you knowing. So all the actions are hidden and then revealed. It's also zero-sum in that there's just a winner and a loser. And some of the games we'll study will be zero-sum, but not all. So you can have a situation where, if we were to play rock, paper, scissors, and I score 2 points on if I win with rock, and the other player scores 2 points if they lose with scissors, it would be both of our best interests to play rock, scissors over and over and over again, because they would be accumulating points and we would be accumulating points, and the result would be we're better off than just actually playing the game competitively, because we might lose some points or score 0. To make a display of the game rock, paper, scissors, we have to list all the moves possible. So because there's 3 moves for me and 3 moves for my opponent, there's 9 total moves. In game theory, we talk about the row player and the column player. So we can imagine that I could be the row player, so I would select which row of the payoff table to choose, rock, paper, or scissors. And then my opponent, without knowing my choice, selects the column. So if I select rock and my opponent selects paper, then the corresponding spot in the table is -1, indicating that the row player has lost 1 point relative to the column player. Whereas if I select paper and my opponent selects rock, now the paper-rock intersection is 1 point. I'm up 1, if that's the result. So the chart summarizes the score outcomes of all 9 possible combinations of moves in rock, paper, scissors. So that's how to display a game in simple game theory. When we have the opportunity to both score points at the same time, then each of these cells will be populated with 2 numbers. The first number will be the row player score, and the second number will be the column player score. So given a game like rock, paper, scissors, we'd like to be able to decide what's the best move given these alternatives. And there are a couple different methods we can use